Hi everybody, so the concept here is to go over some basics of what's called item response theory. And by absolutely no means, the intention here is to go really deep. It's really just to give you the general concept. So the idea behind item response theory is that whenever you are trying to measure what we call a construct or a latent construct, something that you believe that it exists but you cannot measure directly. So some classical examples of this would be, for example, quality of life or depression or anxiety or whatever, activities of daily living, ability to perform activities of daily living. What's common among, all of these concepts or constructs is that you believe that they exist. So you believe that there is such a thing as something that we call depression, but you cannot like measure depression directly. So what you have to do is to create a number of different questions, and then through these questions and through the something quantitative, some kind of modeling about these questions, then make inferences about the degree or the amount that a certain person might have of each one of these constructs. So for example, if you're trying to measure depression, some of these questions or items, so we're going to be using the terms items, so now you know where the item from item response theory comes from. So if you're trying to measure the amount of depression, you could ask questions like, do you feel blue or did you feel blue over the last week? Did you have trouble getting out of bed? Out of bed. Or did you, do you feel like crying all the time? Do you have any suicidal ideas? Do you think about, hurting yourself? So all of these are things that indirectly they measure depression, or they can indicate symptoms of depression. Now, none of them isolatedly, in an isolated fashion, can measure depression, but the idea is that the combination among them can actually do that. Now, what item response theory does is to take each one of these questions in separate, and try to measure their relationship with the construct that you're trying to measure. So in item response theory, it's classical that you represent the construct or the amount of the construct by this thing called theta. Okay, so theta here, and I'm going to put a scale here which is sort of arbitrary, but you have 0 here, and then you have 1, 2, 3, 4, and then here you have -1, -2, -3. The only thing that these numbers mean is that 0 will be the average construct for the population that you are measuring. It has no other special interpretation. So basically this is what you have on the x-axis, and then here what you're going to have is the probability of getting that answer right, or giving a positive response to that question. So if the question here is, for example, you know, did you feel like crying over the last, did you often feel like crying over the last week or so? Is the cry question. This would be the probability of the person answering yes. Um, in the, I'm just going to change the color here. So for that question, we would have a curve that looks more or less like this. So it's basically an S-shaped curve, okay? And then there are basically three parameters that you can measure for a given item curve. And actually this curve here is called the item characteristic curve, ICC. Just take another color here. I'm going to use something whitish. And now we're going to identify the three parameters. So the first parameter is actually where, in the middle of this curve, which point of this item. So again, just to make sure, this curve here represents this specific question. So it's basically about the question about crying. So the parameter that we call the B parameter is the parameter that identifies this item in relation to the um, amount of the construct that you are measuring. So if here what we have is depression, all we're saying is that compared to all the other items that you are comparing this item to, so the items about blue and being blue or having suicidal ideas, uh, the one about crying is associated in this case with an amount of the construct, in this case depression, of somewhere, this would be something like 1.1, say, so, or minus 1.1. So this is the first parameter. The second parameter is what we call the A parameter, which is the slope. Now the slope for this item just means how accurate or how precise this item is in relation to identifying the amount of the construct, in this case depression, to this parameter B. So let's just give a few examples here. Let's say that I could give you three different items. The first item looks like this. Basically, it has a big slope. The second one has a slope that looks like this. So basically, for this second one, what you can see is that the slope is really, it's much greater. And this slope here, it's much smaller. Uh, what this means is that this item here, which has the greater slope, it does a much better distinction between people who said no to this item versus people. So why do I know that they said no? Well, basically because the probability of them answering for so this is the probability of answering yes or 1, and this is the probability here of answering no. So basically, if they said no to this item, very likely they are on this side of the construct. If they said yes, very likely they are on this side of the construct. Whereas for this second item here, because it's completely flat, if they say no, well, they could be on a wide range of places in relation to the construct. So this second item, which has a lower slope, is not good in terms of making the distinction between people who have a degree of depression that's lower than this versus people who have a degree of depression that's greater than this. So basically that's the second parameter, parameter A. And then there's a third parameter, which we call the C parameter, which is the distance between the zero probability and a probability that's a bit above zero. Now the C is also called the guessing parameter, and it basically for biomedical scales, it just means that the item is confusing to people. So people are, can't really interpret what you're saying. So if I'm trying to think about something here. Let's say the question about being blue. Okay, so if you ask somebody whose first language is English, they are going to immediately understand blue to mean sad. Okay, so I'm blue, I'm sad. Now, if you take somebody whose first language is not English but speaks some language, some English, they might interpret blue as being the color blue, and they have absolutely no idea what you're talking about. So whenever you ask them whether they are blue, they might say, "Well, blue in my language, blue is a happy color." So if you mean blue, you're probably asking if I'm happy, and they're going to get the question wrong. They're going to interpret the question wrong. So the C parameter basically means that they didn't really understand the question. Now that's the basics for IRT for this video. Later on, we're going to talk about some other details. Bye.